So as we start what we did yesterday was just labeling the unit circle, really focusing on angles, getting it in the right position, getting to those reference angles. We saw that we could narrow things down to be between 0 and 90, which is what we want, because 0 and 90 we can eventually get to trig functions, which we bring in today. Now as we start to do that, though, let's just focus on quadrant 1. So quadrant 1 is a nice one to start, because in any other quadrant we want to go to is going to be a reflection of quadrant 1. So in quadrant 1, we said we would have 0 degrees, 90 degrees, and then we're going to do 60, 45, and 30.
How do you know that? We got that.
Now, we use those because those are the special right angles we have. It says radian measure. Don't worry about that. We'll do that next time. Okay, so for right now, today, we can do everything we need with just degrees. What our goal is to start figuring out the coordinates that would go to that. Remember, this is a circle with a radius of 1. It's a unit circle. If we know the coordinates, it's going to make our trig a lot faster. So, coordinates I already know. I know I got 1, 0 at 0 degrees, and I have 0, 1 at 90 degrees. So let's kind of go through each, the 30, the 45, and the 60. Now, as we do that, I have the triangles kind of in the middle column. And that's each one of them, because I could go from that point that I have and drop down and make a triangle. I could go from the 45, drop down and make a triangle, and the 60 to drop down and make the triangle. And that's what I have in that middle column. So we can kind of think triangles for that. Now, we don't have all the triangles drawn because the unit circle already has enough information. That would just completely lose us if we drew all those vertical lines. So let's just go one at a time. So let's go a 30 here. So if I had a 30, 60, 90, not even unit circle, just 30, 60, 90, and I wanted the basic form of it, and I just make the short of side 1. What's the hypotenuse? This is 1. 1. 2. Okay. And the longer leg?
1 radical 3.
1 radical 3. 1 root 3. Or just root 3. Okay. So from that, I could then come through and say that sine of 30 is what? I kind of did this last week, earlier this week. 1 over 2. Okay. Cosine of 30. 3 over 2. And then tangent of 30. I've been 1 over root 3 becomes root 3 over 3. Okay, and we can do that. We can go through and use them. But the thing is, that's not a unit circle. We know that's not a unit circle because if I took this triangle and transposed it over here, the hypotenuse here is 2, where our unit circle, we've said it's a radius of 1. So using our knowledge of similar triangles, let's just divide all those values by 2. So now in my next triangle, I have 1, 1/2, and root 3 over 2.
How come it's root 3 over 2, though, when it's a unit circle? So when it, both of those...
To get the...
radius. Oh, it never...
But remember, it's this triangle here, off the 30 degrees. Okay? So, I have those values. Now, I could take these and apply them over here, because really that would be the x value would be how much I went over. Again, let me draw the triangle in. That would probably help us. We're talking about this triangle. So this triangle in here is 1, 1/2, and root 3 over 2. So my coordinate here is root 3 over 2 and 1/2. I went over root 3 over 2, up 1/2. And there's my coordinate at 30 degrees. But wait a minute, root 3 over 2 and 1/2 looks familiar. Where did we already see that?
Aren't those the formulas for...
No, on the same screen. 1/2's the y value. What else is 1/2?
The sine value.
Sine. Oh, sine of 30 is 1/2. The x value, root 3 over 2. Oh, cosine was root 3 over 2. Do you think that the sine value is going to be y and the cosine value is going to be x?
Yes.
Always?
Yep. No.
We should check another one. Let's look at the 45, 45, 90. Okay, 45, 45, 90. I have 1, 1, and root 2. If I went through and wrote them, I'd have sine of 45 and cosine of 45. They would both be 1 over root 2, which is root 2 over 2. And cosine, same thing. Tangent is what? Tangent is 1. So I took everything there and said, root 2 is great and all, but I need a hypotenuse of 1. Similar triangle, so I could divide everything by root 2. Well, dividing 1 by root 2 leaves me with root 2 over 2, which is my y value. And root 2 over 2, which is my x value. So again, now my coordinate here is root 2 over 2, which was cosine, and root 2 over 2, which is sine. So this coordinate, the x value is cosine, the y value is sine. Which is really the trig ratios. Because if I said, hey, write trig, the trig ratio, the sine of 45, you do opposite over the hypotenuse. This is opposite divided by the hypotenuse. Hypotenuse is 2. I basically took everything and divided it by the hypotenuse. To be root 2, and I simplified. But we're simplifying down. So, down here it's 60 degrees. This starts out as 2, 1, root 3. When I make this into 1, what do I get up for the bottom side? 1/2. And the other side? 3 over 2. So my coordinate up here at 60 degrees is 1/2 root 3 over 2. So that describes where that point is. Now, that's great. No, we get the point. That's not the point of it. No point. No. All right, let's try that again. We got the points, but really our goal here is we want trig ratios. So we can actually now say, hey, if I got the unit circle, sine of theta is the y value in the coordinate. Cosine theta is the x value in the coordinate. Okay? Tangent. We haven't really seen tangent pop out to an answer yet. So we got what we had? Root 3 over 3. We had 1. Tangent would have been root 3 on the last one. Tangent's actually a fraction of sine and cosine. Which one's on top?
Cosine. Sine.
When I said tangents, tangent, TOA, when I say that, what do we say?
Choices.
What is tangent? What fraction?
It's a fraction of sine over or cosine.
Opposite over. So opposite is what? X or y? Y over x. So here we could say tangent theta is y over x. Which also means it is sine of theta over cosine theta. Now we're going to get more into that relationship later. The fact that tangent theta is sine theta over cosine theta. But now we kind of have these shortcuts. If I know the coordinates and it says sine, y value. Cosine, x value. Tangent, y over x. Now, jumping ahead a couple minutes. If I then ask for secant, cosecant, cotangent, could you use these to find it?
Yes.
The reciprocal, right? Cosecant would be 1 over the y value. Take the reciprocal of whatever the y value is, you get a result. So we have these to now help us. We just now need them all together. Okay? So we have to fill in our unit circle using quadrant 1 as the basis. So we got these filled in. What quadrant do you want to go next? You want to go 2 or 4? 2. Okay? So,
Left is law.
general rule over here, we say it's x, y. If we went over to the top left, quadrant 2, what is that? What happens to the values?
Negative x, y.
Negative x, y, okay? So what does this angle right here become? How far is this angle from the 180? 30 degrees, so it's going to be 150. So that is standard position of 150. It has a reference angle of 30 degrees. We put a little 30 degree right there. Okay, so yesterday the goal was to get the reference angle. So now we need to start getting programmed that when we see 150 degrees, we're not like, how are we supposed to find sine of 150? We go, no, 30 degrees. Find the values. We've already kind of done the work, though. If I look at 30 degrees over on quadrant 1, it's a reflection. It flipped over here. So my x value changes. So it's now negative root 3 over 2, 1 over 2. Change the sign of x. Now this would have became a triangle. Why does it keep sticking to the 2? There we go. I guess so. Okay, this triangle would have been 1, 1/2, and negative root 3 over 2. That is the side values labeled in it. I know in the past we said you can't have a length that's a negative, but we're talking a coordinate, and we've really thrown all past knowledge out the window as we started to say angles more than 180, but it's going to go in the negative x direction. So, negative root 3 over 2, up 1/2, hypotenuse of 1. We always want a hypotenuse of 1 in the unit circle. Okay, let's go the next step up. It's right here. How far is that from 180?
135.
45, so it's 135. You guys answered both questions at the same time. That's good. Okay, what is the new coordinate going to be?
Negative root 2 over 2.
Good, negative root 2 over 2, and?
Root 2 over 2.
Positive, yep. So negative x, positive y. Okay, last spot in there. 120. Reference angle of? If I drew the triangle here, what would the angle
60.
over here be?
60.
Yeah, it'd be a 60. It's a 30, 60, 90, but it's the 60 here. So it's the reflection of the 60 degrees. So what's our coordinate?
Negative 1.
And?
Root 2. Root 3 over 2.
Root 3 over 2. Okay, let's jump to quadrant 4, down the bottom right. It becomes, x, y becomes what coordinate?
X and y.
Negative y. So the same process we just did where we changed the x's to negatives, you're going to change the y's to negative. So right here, what do we get? Give me the coordinate first, then we'll fill in the degrees. Okay, it's this one, right? X stays positive, y becomes negative. Root 3 over 2, negative 1/2. Okay, what's the next coordinate? And negative, okay. Last one. Okay. Now let's fill in our angles. We'll go the one closest. Negative 30 degrees is true, but we want to say it has what? Yeah, 330. We could say negative 45 for the next one, but as a positive angle, it'd be what?
315.
And negative 60 or?
300.
Okay, forgot my 270 down here. All right, so what are x, y becomes what down here? In the last quadrant. Yeah, they're both negative. So this is taking both these values, changing both their signs, filling in the angles. Should try to fill them in.
210, 225.
Good.
270.
What'd you say, 40? Okay, I've got my 180 here. And then the negative 1, 0. All right, now, we're not going to use this one directly yet, but when we get to cosecant, secant, cotangent, they are reciprocals. Cosecant would be 1 over y. Secant would be 1 over x. And cotangent would be x over y. I would write those off to the side because those are the ratios that you're going to need. So where we're getting to is it's going to say one of those ratios of one of those angles. And that's what we need to find. So, for example, if we just took a basic one and said sine of 45. Go, 45, y value, root 2 over 2. And we got it. If we said cosine of 60, x value, it's 1/2. And we got it, we're done, that's the value we need. We can make them more difficult. You have to do y over x, we have to do reciprocals, and that's going to be a little bit of simplifying, but this is all we're going to have. These are the angles we have to choose from. Those are the points that they have, and off to the right are the ways we're going to write the answer. You're not going to sit there and recreate the new triangles every single time. Yesterday we figured out that if we had any angle and we can put it in standard position, we can make a reference angle, one of these, we can then find the ratios. So, we have everything now, we need to start going through and solving the problems. So, let's pick an angle. You want me to pick one, or do you want to pick one?
182.
Let me rephrase that. There's your multiple choice options for one of the angles to pick. 315.
Cosine.
Okay, wrong arrow. 315 goes to here. 315, that gives me a reference angle of 45. And we're going to get good enough at this that when we see 45 degrees, we go, oh, that's the root 2 over 2 one. Because it's isosceles, these two are the same. Okay? One of them is negative, though. Which one? Y value. Okay? We could also, because the coordinate still works, you could also write this as root 2 over 2, negative root 2 over 2 as well. Okay, so, and hypotenuse is 1, of course. What's sine of 315? Here's sine, what do we look at?
Y value.
Y value.
So it's root negative, no, it's negative.
Negative root 2 over 2. Done. That was easy. We'll do another one. Cosine of 315. It's the x value. Root 2 over 2. Tangent of 315.
Negative
Are those two values both the same?
negative 1.
Except the one's negative. Yeah, so it's going to be negative 1. Okay, so I asked you for one of them. We have the values. Let's do another one. Okay? Give me an angle in quadrant 3. 225. How about one that's not 45 degrees?
30.
210. All right, 210 gives me what reference angle?
30, 50.
30. Okay? Which values, x and or y, are negative?
Both.
Both of them. Okay? Now, maybe I've spaced out and I forgot what the coordinate is.
Negative 1.
My unit circle has rolled away.
But negative.
Okay? Well, I know it's a 30, 60, 90, right? So I know that's 1, that's root 3, and that's 2. But I can just come in and divide everything by 2. And I have the values I need. If I remember, sine of 210 is what? It's the y value. Or negative 1/2.
I don't think that's correct.
Cosine of 210.
Negative root 3 over 2.
Tangent of 210.
1.
That is negative 1/2 over negative root 3 over 2. Well, it's positive 1 over root 3. But we have to simplify that.
Yeah, root 3 over 3.
Yeah, root 3 over 3.
How did you...
Since they both are negative, it becomes positive, and they both have a denominator of 2. So the 2 that comes out, you're left with the numerators. It's 1 over root 3.
I don't understand how you...
Why do you divide all of the side lengths by 2?
I wanted to get the hypotenuse to be 1, because when the hypotenuse is 1, sine is the y value, cosine is the x value. Now, if you didn't want to do that, let's say you don't want the fractions. Let's say we just said 30, 60, 90. So this is a 30. You could have gone through this problem and said that's negative root 3, and that's negative 1, and that's 2, because it's in quadrant 3, x and y are negative. And you can go through these and say sine of 210 is opposite over hypotenuse, and it's negative 1/2. Cosine of 210 is adjacent, negative root 3 over 2, and get it there. That's not using the coordinates, that's just using sine, cosine, tangent, and that might be the way you start through it, but it's just getting to those ratios. Label them correctly, the 30, 60, 90, and make sure you pay attention to your negatives, x and y, depending on your quadrant, and you guys will be able to get to them. Okay, do you want to do one more before you start off and try some?
Yeah.
Okay? What quadrant do you want to go into?
2.
Quadrant 2, give me a value.
150.
150. I hear 150, what's my reference angle?
30.
Yep, 30 degrees. Okay, let's just treat it like this problem. 1, 2, root 3. Which one's negative?
X, so...
That one?
Yes.
Okay. What's sine? You could either look at that triangle, or you could look at your chart and the y value.
1 over 2.
Yep, it's 1/2. Cosine?
Negative 3.
Negative 6.
Root 3.
Or negative...
Negative root 3 over 2. Okay, so in this one, you got to write the fraction. On the unit circle, you can just use the x value, which would be negative root 3 over 2. Tangent?
Negative root 3.
Would be negative root 3 over 3. Thank you for the yawn. Okay, and then you could go through, we could find the reciprocals. Right now, they're not going to have the reciprocals. You're just going to get sine, cosine, tangent. Second part of this, we'll give you some reciprocals to work with. Okay? So, on your packet, 7B4 problems, so it's the next page. You have these.